This video comprises a tutorial sheet on sketching of root loci. So the idea is that these are questions so that students can try out their own understanding. In order for them to do that, students need to pause the video after they've read the questions and attempt the questions themselves. Only look at the answers provided here once you've had a proper attempt. A bit of background. This is about root loci. We're assuming simple feedback loops of this form. We're assuming that you can write GM or reduce it to the form k n over d, where k is a scalar gain and n over d comprises all the dynamics. And the closed loop poles are given by either this expression here or this expression here. Now the rule summary that we expect you to use to solve these problems is given here. Rule 1, mark open loop poles with a cross. Rule 2, mark open loop zeros with a circle. Rule 3, compute the asymptote directions by finding out the excess of poles over zeros. Compute the asymptote centroid, so you know where to put the asymptotes on your root loci plot. And Rule 5, add the parts of the loci that are on the real axis. And then you join your observations with smooth curves, noting the warning down here that the loci depart the real axis at a 90-degree angle. So examples. You'll see there's 4 examples here for you to try, and what we want you to do now is pause the video. And I will continue with some solutions, but please do not continue until you've tried them by yourself. So first example. G equals s plus 1 over s times s plus 2 squared plus 1. So the first thing we need to do is give ourselves an appropriate axis. So I'm going to mark an axis here with scales a bit like that, where those marks basically denote 1, 2, 3 and so on. Now you can see that we've got open loop poles at -2 plus or minus I. So therefore I've got an open loop pole here and an open loop pole here. I also have an open loop pole at the origin. Perhaps if I write that down so you see you've got poles at -2 plus or minus j. If you couldn't see it, that's from this quadratic factor in here. I've also got an open loop 0 at -1. So I've marked that. Next, I want to see how many asymptotes I've got. Well, the excess of poles over zeros, k minus m, is 2. So the asymptote directions in this case are going to be plus or minus 90 degrees. Next, I need to know where to sketch the asymptotes. So I need the centroid. So the centroid is given by the sum of open loop poles, which is going to be -2, -2, because there's 2 of those, minus the sum of open loop zeros, which is -1, all divided by 2. And so what you're going to get is -3 over 2. So I can mark the asymptotes. There's the -3 over 2. So I draw my plus or minus 90 degrees with the centroid -3 over 2. Oops, what happened there? And there you can see the asymptotes marked. Now I can add the bits of the real axis which are on the loci by counting odd numbers to the right. So in here I've got an odd number to the right and nowhere else. And finally I can maybe use a darker colour to see exactly what happens. So this pole clearly goes to this 0, and these 2 poles will move off and go towards the asymptotes. Next example then. So again, the first thing to do is to give myself an axis so that I can see what's going on and put a suitable scale on this. So I'm going to need a point over here which is 10. So I'll put that one as -5 and then put some markers down there so you can work out roughly what those are. And similarly, if we put a 5 there and put some markers down here, so I've got some rough scales. You can use proper graph paper if you have it. Next, I'm going to mark down where are the poles and where are the zeros. So I have a pole here at the origin, a pole at -2, a pole at -3, and a pole at -10. I've also got a 0 at minus 1. Next, work out the excess of poles over zeros. So in this case, I've got k minus m equals 3, and therefore my asymptote directions are going to be minus 180 and plus or minus 60. Next, compute the centroid. Well, the centroid's going to be minus 2, minus 3, minus 10, that's the open loop poles, minus 1, that's the open loop 0, all divided by 3, and that's going to give me minus 4 and 2/3. So I can mark that point, it's going to be roughly here. You'll see I've put a red dot. Next, I need to mark the asymptote, actual asymptotes. Now remember, plus or minus 60 degrees means that it's going to go a bit above 5j when it crosses there. Again, you can be precise if you want to, mark that 60 degrees, but the asymptote directions will be something along those lines. Next, add the parts of the real axis which are on the loci by looking at the odd number to the right. So between here and here, I've got an odd number to the right. Between here and here, I've got an odd number to the right. And obviously, over here, I've got an odd number to the right. And finally, let's use some darker lines to mark the actual loci. So this one on the left is clearly staying on the real axis and going off to minus infinity. These two clearly come together, separate, and then go towards those asymptotes. And this pole goes to that 0. Example 3 then. So again, we'll start by drawing the axis that we need. So we'll draw that down there, draw that across there, and we'll put some scales. Hopefully that'll be just about enough for us to work with. And now let's mark the poles and zeros. So I've got a pole at plus 1. There it is. A pole at minus 2, a pole at minus 4, I was a bit careless there, and a pole at minus 5. There we go. I've got a 0 at minus 1. So what's the excess of poles over zeros? I've got k minus m equals 3, so therefore my directions are minus 180 degrees and plus or minus 60 degrees for my asymptotes. Next, I need the centroid. So the centroid, I've got to calculate the sum of poles, so I get minus 2, minus 4, minus 5, plus 1, then minus the open loop zeros, which is at minus 1, all divided by 3, and if I solve that, you'll see I end up with minus 3. So, the centroid for the asymptotes is at minus 3, and you'll see that little red dot I've put there. Again, I need to mark my 60 degree directions, so that's going to be something along those lines there, and also this one obviously going off to minus infinity. Next, add the parts of the loci on the real axis. So I need an odd number to the right, so there's an odd number to the right in here, there's an odd number to the right in here, and there's an odd number to the right over here. And finally, let's do the actual loci. So clearly that one is staying on the real axis, going off to minus infinity. These two are coming together, joining, and going off to the asymptotes. And this one is clearly coming to the left and going to the 0 there. Final example then. So again, we'll do our normal trick. We need to add ourselves some axes that we can use. So I'm going to need to be a bit more careful here. So we need to go up to 3. So hopefully that's about good enough. So now let's add our poles and zeros on. So we've got a pole at the origin, a pole at minus 1, a pole at minus 2, and a pole at minus 1/2. We've also got a 0 at minus 4 and a 0 at plus 3. Next, let's look at k minus m. Well, in this case, k minus m is 2, so there's 4 poles and 2 zeros, so that gives us asymptotic directions of plus or minus 90 degrees. For the centroid, we're going to get minus 1, minus 2, minus 0.5, and then we're going to get minus 4 plus 3, all divided by 2, so that's sum of open loop poles minus sum of open loop zeros, and that's going to give me minus 1.25. So if I use red to mark that, that's going to be this little red dot there with a plus or minus 90 degrees. Your asymptotes are going to go roughly like that. Next, we need to do odd numbers to the right. So there'll be an odd number to the right in here, an odd number to the right in there, and an odd number to the right in there. And then finally, we'll use back to see exactly what's going on. So this pole is going to that 0, this pole is going to that 0, these two poles come together and go off towards the asymptotes. Now, we've given a number of tutorial questions using the 5 simple rules for sketching root loci. And again, we should emphasize that the key point is these are sketches, not plots. If you really want to plot, go and use R locus on MATLAB or something similar to check your answers.